Okay, we're going to look at what the binomial theorem is today, and it relates directly to this that I just had you guys do. Okay, when you guys multiplied this out, how many terms did you get? Does anybody know? How many terms did you get? No, you should have gotten 5. It says 4, but you should get 5 terms when you're done. Here, check this out. Here, let me write it down. Let's see here. Let's see, where is it? I wrote it down somewhere. Here it is. Okay, we're gonna write. Let me write this down really quick.
Wait, are we gonna take notes? Should I
Not yet. Let me write this down. Yeah, but I'm gonna solve it in front of you guys. Okay. So here we go. All right. So I did it squared first. Twice, and then I multiplied those together, and then as I multiplied those together, this is what you got, and then when you combine like terms, this is what you're getting, and then you guys like that? I write really fast, huh? That's your answer, and so we got 1, 2, 3, 4, 5 terms. Now there is a faster way to expand these binomials. That's what this is. It's a binomial. It has 2 terms. And when you expand them, when they're raised to a power, it can get pretty hairy. But there's another way to do it. And that's by using combinations. Okay? Yeah, I erased it. But you don't need it right now. Okay? This is a combination. This is another way to write combination. You guys know combinations like this. Okay? 4 choose 0. Well, 4 choose 0, this is the same thing. It's just written a different way. So they're the same. Okay? So you always start with 4 choose 0. That's for the first term. And then for the first term, you also need to have the 2 terms inside the binomial. So we have the x and the negative 2y. And I'm going really slow here to show you guys how to build it. And once you know how to build it, it becomes a lot more... you remember it a lot faster for when you need it. So this first term and the second term both need an exponent. This first term right here always starts off with the exponent that is on the binomial. You see down here? You see the answer? It always starts off with it. And so the other one has a 0 for the exponent. That's the first term. That's going to give us our first term right here. We'll take a look at that in a second, but let's build the rest of it. The next one is 4 choose 1, and then the first term raised to the 3rd power, the second term negative 2y raised to 1. Okay, the 4 went down 1, and the 0 went up 1. And then you could also look at or you can also look at the combination that you're doing right here, and get your exponents based off the combination. The 1 is always the exponent on the second term, the number that you're choosing, and then 3 is always the difference. So let's take a look at what the next one looks like. What do you think the next one's going to say first? It's going to be 4 choose 2. Yeah, good. So 4 choose 2, and then we get our other terms in there. And then look, notice that the 2 right here is the 2 for the choose 2 right here. Is the exponent for the second term, and then that 2 we get that 2 by doing the difference of these 2 numbers. All right, let's do the next one. So it's 4 over 3, or 4 choose 3, I should say. 4 choose 3, and then you have the first term raised to the 1 power, and the second term raised to the 3rd power. See, the choose 3 is the same as that exponent right there on the second term, and then the difference between 4 and 3 is 1. And so we put that exponent on the first term, okay? Finally, the last one. Do you guys think you want to guess the last one? But what's the green part for the last term? It's 4 choose what? 4 choose 4. Okay, so we write 4 choose 4, we write our terms. This time the first term has a 0 exponent because the difference of the 4 and the 4 is 0. And then choose 4, 4 goes on the last of the second term. After you know how to set it up, then you can start working it out. Now, 4 choose 0 equals 1. 4 choose 0 equals 1. And then when I raise x to the 4th power, I just get x to the 4th. And then this raised to the 1 power is just 1. And that is our first term. Right? If we multiply these together, we get x to the 4th. The next one, 4 choose 1 equals 4. Our second term is x to the 3rd, and our third term is negative 2y. And it's negative 2 because it's an odd exponent. It stays negative. And then when we multiply those together, we get negative 8. We get our term down here, our second term. 4 times x to the 3rd times negative 2y. Negative 2 times 4 is negative 8. Okay? And then the next one, 4 choose 2. What's that one going to give us? Do you guys know? I mean, you could actually figure it out with factorials and everything, but there's a fast way to do it. You guys can look at Pascal's triangle. It's 6. 4 choose 2 equals 6. If you look at Pascal's triangle, if we actually figure this out using factorials. And then x squared, that one's obvious. And then this one, negative 2y raised to the second power. That's negative 2 times negative 2. Negative times negative is a positive. Because that's an even exponent, it's helpful to know that you're going to get a positive number here. Then you have y squared. And then when you multiply those together, you get 24, positive 24, x squared, y squared. Okay, for the next one, 4 choose 3. Come on, anybody want to take a guess on that one? Yeah, that one's 4. That's at the end of Pascal's triangle in the row. And then we do the rest of them. X to the 1 is x, and then negative 2y to the 3rd power is negative 8y to the 3rd. It's an odd exponent, so you know it's going to be negative. It's going to stay negative. And then when we multiply the negative 8 and the 4, we get the 32. And then we have the last one. 4 choose 4 is just 1. X raised to the 0 power is 1. And then you have negative 2y raised to the 4th power, and that gives you 16y to the 4th. And so we get the same polynomial right here, but using something called the binomial theorem. Okay, this is binomial expansion. Some of you guys are thinking like, well, I could probably just multiply this out and it'll be faster. Yeah, but if you are using Pascal's triangle, it won't be. See, look at these numbers. Do you guys notice anything about those numbers? If you don't, look at your Pascal's triangle. Look at the 4th row. Right? See the 4 right there? Look at the 4th row on Pascal's triangle. Aren't those numbers the numbers on Pascal's triangle? Yeah. And so you could just use those numbers. You won't even have to write the choose notation. Does that make sense? Kind of cool, yeah? Show you a type of problem that this is really helpful with. I only have one example. Here, it says, what is the nth term for the following binomial? Now, for this problem, what does that mean, nth term? N equals 4, so what does that mean? Yeah, it wants the 4th term. Okay, so you could multiply this out if you really want to the 7th power. But that doesn't sound like very much fun. Or you could try to figure out the pattern using the binomial theorem. Okay, now, I'm going to write this shorthand way. The very first term would be, what would be the top of the choose? It would be 7. That's because of the exponent right there. 7 choose what for the very first term? 0. And then you'll have some stuff written after it. I'm kind of skipping that part because I want to get to the 4th term. The second term will be 7 choose what? Okay, that's the second term. And then the third term, whoops, I forgot to put my stuff right there, plus, what is this, the third term? 7 choose what? 7 choose 2. And then some stuff right there. Plus, okay, finally, we're at the 4th term. This was our first term, our second term, our third term, and for the 4th term, it's 7 choose 3. And then the first term in the binomial is x. The second term in the binomial is, x is the first term. Second term is negative 10y. And now you just have to figure out, okay, what are the exponents for those two terms? Remember what we were talking about before? We know that the 3 always matches the exponent on the end, or the choose number. And then the exponent right here for the first term in the binomial is the difference of these two. So what's the difference of those two? 4. You know you did it right when these both add up to 7. They always add up to the exponent that's on the binomial. Okay? And then you could, since it's 7, that's on your Pascal triangle, or you can like keep going and find other rows if you need to. But yours, the one that I gave you guys, goes down to 7, and you can look in the Pascal's triangle, or you can figure it out. 7 choose 3 would be like this. That would be 7 factorial over 7 minus 3 factorial, 3 factorial. And so this would be a 4 factorial. And I could rewrite this as 7 times 5 times 4 factorial over 4 factorial times 3 factorial. And the 4 will cancel out. The two 4 factorials will cancel out. 3 is written as 3 times 2 times 1. And you could, you can get rid of, oh wait, I forgot the 6. Okay, get out of here, 7. That's where 6 goes. We could cancel out that 2 and cancel out the 6. It becomes a 3. Cancel out the... Oh, the 3 and the 3. Cool. So now it's a 1. So 7 times 5, what will that give us? 35. So we have 35 right here times x to the 4th times... Ooh, what is 10? Negative 10 raised to the 3rd power. Well, we know it's negative because that's an odd exponent, and it'll have 3 zeros because it's a 10. And it's y to the 3rd. So then you have negative 1,000 times 35, so you have 35, negative 35 with the 3 zeros on it, x to the 4th, y to the 3rd. And that is the 4th term in this binomial expansion. Okay, so I just wanted you guys to set this one up, just to give it a shot. N equals 6. So how would I set up the combination part? Just setting it up. We know that it's 7 choose what? Okay, you're choosing 5 because remember you always start with 0, so 5 would be your 6th term. And then you have x is your first term, and negative 10y is your second term. What are the exponents?
2 and 5.
2 and 5? Okay, yeah, this one's 5 because it matches the choose, and this one's 2 because it's the difference of these two. Or you just think the 2 and the 5 have to add up to 7. And that's how you set it up. And now you just have to, do your calculations and you're done. Sweet.